All right, Math 3, let's get going on this. So, even though I'm not here, my voice is here, and that's going to be enough. So, now the paper I gave you doesn't have this section on it. It's just going to have all these pieces, okay? So, and this is still one of those tasks, so the idea is still looking at it and trying to figure out what's going on. It's the process that's going to help you, okay? So, on probably a separate sheet because I don't think you have enough space, I want you to try this. So like I said, on a separate sheet of paper, just pick a number, okay, any number, add 6 to it, multiply that by the multiply your result by 2, that's weird, subtract 12, divide 2, and you should get the answer the number you started with. So let's pick just a random number, 31. Okay, if I add 6 to it, that will give me 37. If I times 37 by 2, that would give me 4. And then one up here, 674. Then I subtract 12 from that. That would give me 62. And then divide 2 takes me back to 31. So, you've probably seen tricks like this before, and people are mystified and all that kind of stuff. But if we look at this as a function, okay, it's going to give us the same thing, okay? And thinking about what we learned last time about inverses being opposites of each other, that's going to be very helpful as we do this, okay? So notice 6 times 2 is 12, subtract 12, divide by 2, end up with the same thing. So, let's take a look at what we're going to be doing here. So, you're going to start with your input, okay, that's in the number there, so we've got x equals 7, okay, and we're given our function as well, okay, down here, so we input 7 into that x, that's where the 7 plus 8 is. So, we started with 7, we put it into our function, we get 7 plus 8, which equals 15, okay. Now, how do we go back to get back to that same input, to have that as our output, okay? And that's what you're going to be figuring out, is what is the inverse that will take this result and get it back to have the same output that your input was, okay? Kind of like with here, adding 6, timesing by 2, dividing by 12, or minusing 12, dividing by 2 took us back to 31. Same concept here, okay? So let's take a look at another one to kind of help you think through it, okay? Actually, no, let me make up a different one. Okay, so let's take a look at this. So I've got x equals 7, and I've got a function here. So I'd plug 7 into that function. Okay, and that's what they wrote up here, what it looks like when it's plugged in. And what would that equal? Well, 2 times 7 is 14, minus 10 would give us 4. Okay, so now how do I take 4 and get it back to be 7? Okay, what do I have to do? Now you might say, well, you just add 3. True, we could do that, but I want the inverse. How could I apply the same process? What would my inverse look like to go from 4 back to 7? Okay, well, when we're talking about inverses, think backwards in the opposite direction. So first, when I had 7, I times by 2, then I subtracted 10. So we timesed 7 by 2, then we subtracted 10. We want to go in reverse order and do the opposite. So I want to add 10 first, and then divide by 2. So I'd go 4 plus 10 divided by 2. So my function would be x plus 10, all of that divided by 2. And if I put a 4 in there, 14, 4 plus 10 would be 14, divided by 2 would give me 7. Okay, so hopefully that makes a little bit more sense as to what I expect from you. So you're given the input, which is always going to be 7, the function, so I plug 7 in for x, 3 times 7 is 21. Now, using the inverse operations, what would my function be if I plugged a 21 in and took it back to 7 using the opposite of what's happened? What's happened, not been happened. Okay? So, I want you guys to try number 1 and number 2 first. Let's give ourselves about 4 to 5 minutes. So, right now, the guest teacher needs to pause the video, give you guys about 4 to 5 minutes to work through this. Then you can play it, and we'll go through these two, and we can see how we do, and we'll just kind of jump like that through all of these, okay? If you get done with the first two, feel free to keep going and get ahead, and then just wait to play them, okay? So, pause that now. So I'm assuming it was paused. Hopefully that we're paying attention and we got it done, okay? So, these two should be done by now, and you should have tried your own problems. So, first thing, 7 got plugged in here for 3 times 7, which gave us 21. So now the only thing that happened to x here was that we times by 3. So for our inverse, we want to do the opposite, right? Divide by 3. So I'd go x divided by 3. So 21 divided by 3, is that 7? You betcha that is. So that's my inverse to that one. It undoes what's been done to the function. Okay, and that's what we're looking at showing. So number 2 now. So I've got 7x squared, so f of 7 equals 7 squared. 7 squared is 49. So now I think, okay, what's the inverse operation of squaring that will take me back? So if I need to, what happened to x? Well, we squared x. How do we undo a square? We square root it. So my function should be the square root of x. So this 49 is my new x. Is the square root of 49 7? Yes, it is. That's my inverse of this one. Okay. Notice my inverse functions, just like when we talked about the, if you remember last time we had the 7/5 times dollars and the 5/7 times pounds with Brutus bites. All right. So, lost my train of thought. Somebody came into my classroom while I was making this, visiting me, gave me a nice little gift. That was nice of them, former student. Just shows you how awesome I am and how much you guys need to pay attention. And those in the back probably need to stop looking at their phones so that they can actually pay attention to this stuff. Okay. Anyway, I think we were done with those ones, so that's what we should have ended up with. All right. So now let's take a look at 3, 4, and 5. Let's give you guys some time. How many of these do we have? Okay, we go to 8. Okay. So yeah, 3, 4, and 5. Let's give ourselves about 5 to 6 minutes. About 2 minutes per each one. It shouldn't be taking you a whole lot of time to do these. Okay. So, pause the video and take a look at these ones. And by the way, skip number 3 if it really throws you off. Okay. Alright, so hopefully you had some time to puzzle over those ones. Number 3 was probably pretty troubling for you guys. Okay, so it's an exponential here. So we got f of x equals 2 to the x, so we went 2 to the 7, which is like 2 times 2 times 2, 7 times. Okay, which gives us 128. So now how do we go backwards from 128? Okay, well, what's the inverse of an exponential equation? That is an excellent question. Okay, so if we remember, x squared, square rooting is the opposite. For a cube, cube rooting is the opposite. So what about for an x? Something to the x power. Would that be an x root? Okay, it's a good start. If you went with an x root, okay, not too bad. Not quite what you would want. I suppose you probably should have put the nth root to be more precise, or I guess we could have put the x root not of x but of 128, and we know that that would get us back to 7 because that's what we were doing. Okay, Oh, I've been forgetting the in the words, right? So you'd take the root of the input. Okay? We'll get more into this as we keep going after these inverses, so I don't want to say too much more about that. Okay? But there is a special thing that we have to do this, and actually what you should end up is something that looks like this. Okay? This one, in words, we take the square root. In words, we divide by 3. Sorry, I forgot about those. Anyway, let's jump to the next one. So we said 4 and 5 as well. Okay? So number 4, we've got 2x minus 5. So we took our 7, 2 times 7, and minus 5. So now remember, on these ones, there are multiple steps, so you've got to think backwards. So what happened to x? Well, first we times by 2, then we'd subtract 5. If x were a number, when we put 7 in, that's what we did. So going backwards and doing it in the opposite order, first we should add 5, then we should divide by 2. So I should go 7 plus 5, whatever that answer is, divide it by 2. So my inverse, x plus 5 over 2. So first in words we would add 5, then divide by 2. All right, now number 5. Okay, so we've got our function, so f of 7 would equal 7 plus 5 over 3. 7 plus 5 giving us 12, divided by 3 would give us 4. So what happened to x here, or what happened to 7? Well, we added 5, then we divided by 3. So for our inverse, we do the opposite. We would times 3 first, then subtract 5. So I'd go 3 times 4, and then subtract 5 from that. So my function, 3 times x minus 5, and that'll get us back to 7. Okay, so hopefully kind of using this method has helped out a lot. All right, so now we need to do 6, 7, and 8. So let's take another 5 to 6 minutes, maybe 7 if you need a few more. Okay, pause the video now and get those 3 done. So hopefully you got that done, and so we can take a look at how you did on these ones. Okay, so number 6. So for f of 7, we would go 7 minus 3 squared. 7 minus 3 is 4. 4 squared is 16, obviously. Okay, so now we need to go backwards. We need to figure out how can we get 16 to go back to 7. Well, what did we do to 7? What did we do to our variable x? First we subtracted 3, then we squared it. So the opposite of squaring is square rooting. Opposite of minusing 3 is adding 3, and we do it in reverse order. So I take the square root of 16, which would give me 4, then I add 3, which would give me 7. So square root of x for our inverse plus 3. And that should have looked like that. All right. So now let's, we did these ones, so taking a look at these ones, we've got 4 minus the square root of x. So we plug in our 7. 4 minus the square root of 7. Okay. Well, what does this equal? Okay. Can we really change it? I mean, we could get a decimal if we use a calculator. If we do that, we get approximately 1.35425. Not too nice to deal with. Okay, but let's think about how we could undo this. So we've got x here, or our 7. So first we'd take the square root of 7. Then we would subtract it from 4, right? So, or in other words, okay, another way to think about that, because 4 minus the square root of 7, we could change that to a negative square root of 7 plus 4. Okay, so that might be a better way to think about it. So if we take the square root of 7 first, then we times it by a negative 1 to get the negative, then we could add 4. So if we're going backwards, we would start out by first subtracting 4, then dividing by a -1, which is essentially the same as timesing by a -1, right? Because that would get us the same thing. Then we would have to square it, okay? So if I took this this stuff, first thing we need to do is we would subtract 4 from it, okay? Then that would all be timesed by a -1 or divided, same thing. Then we would take that and we'd square it, okay? So we could, in other words, we'd go 4 problem here is this is pretty ugly looking, right? So if we did this with a variable, it would be -1 times x minus 4 squared. Well, we could distribute this through, and that would give us 4 minus x, and then we would square that, okay? Which we could try that out in a calculator, and if I go 4 minus that 1.35, all that stuff, get that answer, and then I square it, okay, it doesn't look so nice, okay, and that's the problem. Except I think I might have done it wrong. Let me try this again on my calculator. So if we go 4 minus that, okay, this is better, and then I square it, that gives me roughly 7. So this was a tough one to think through because it almost looks exactly the same. 4 minus x squared. Notice the square root doesn't include the 4. In here it does because we're going in the opposite order. Okay, so that was kind of a messy one. But in words, we would just go 4 minus our number and then squared. And I don't have space to write it. So 4 minus x, then squared. All right, number 8. Okay, so we go f of 7 equals 2 to the 7 minus 10. Okay, once again we have that same type of issue with the exponent, and it was right back here. So this guy is part of it. The thing we have to realize is first we took 7 as a power, then we subtracted 10, okay, to it. So we would need to add 10 and then do the opposite of the power of 7, okay, which would be like the 7th root, wouldn't it? Though that's technically not the same. No, it does work that way. I don't know what I was thinking. So we could write it out that way in this case. So we could go taking the opposite. We would add 10 first, so it would be x plus 10. Then all of that we're going to take the 7th root of, and that would give us our answer. Actually, no, it doesn't. I was right the first time. It takes my answer back to 2, not back to 7, and that's the problem. That's why we end up having to do this crazy different thing and do it like this to make it work. And like I said, I'll talk about that more as we get going. Alright, so we've got 3 questions now. So number 9, 10, and 11. Okay? So what I want you guys to do is try answering these. Take about 5 to 10 minutes. Okay? Depending on how much time is left in class. And this is critical. This is the part that's going to help us. Okay? So pause it right now, and then we'll talk about them. Alright, hopefully you had some time to think through this and you probably struggled with it, and that's alright. Okay, it's that process that will be helpful. So number 9 says each of these problems began with x equals 7. What is the difference between the x used in f of x and the x used in the inverse f negative 1 of x? That is an excellent question. Let's go back to one of our problems here. Okay, let's look at problem number 1. So, is this x the same as this x? Or in other words, is that x the same as that x? Well, this x was 7. Okay, that would be the input, right? So the input was 7. And in this case, the output was 21. Well, what's the input in this one? Well, the input here is 21. And our output is 7. Think about those Brutus bytes and what we did here, that we swapped that x and that y. Okay, so that's why the difference is the x in f of x stands for its input, but the x in the inverse is the output of f of x. Okay, they're swapped, and that was the difference that you should have been thinking about on that one, okay, which is very critical when we're talking about inverses. Number 10 says, in number 6, could any value of x be used in f of x and still give the same output from f negative 1 of x? So let's look at 6. Okay, so if we used a number besides 6, could it work the same? Well, let's try it. Let's use 4. Actually, not 4. Let's use a bigger number, 10. So 10 minus 3 would be 9. 9 squared is 81. Okay. Square root of 81 plus 3. Square root of 81 is 9. 9 plus 3. Did I say 10 or 12? Oh my goodness, I'm having issues right now. So we'll just say we said 12. 12 minus 3 was 9. 9 squared, 81. 9 plus 3 is 12. So yes, it will work in any situation because it's designed, because of this, it was designed to work that way. What about number 7? Okay. Well, it's the same idea, right? It doesn't matter which number you use because the way you set it up is that it's undoing regardless. Okay, so yes, it could because they're inverses and one undoes the other, so you always end up with what you start with. Okay, and that's the point. That's the point of an inverse. So 11, based on your work in this task and the other tasks in this module, what relationships do you see between functions and their inverses? Well, they do inverse operations, would be the fancy way of saying it, in reverse order. Okay, that's hopefully the main idea you got out of it by going through this process. Okay, so you've got a little bit of homework where you're going to try to, it's not very long, but you're going to take a look at recognizing some inverses, and then next time in class we're actually going to see how we do this and we make the inverse. So that's pretty much what we got going on here. If you have time left in class, by all means get that homework, get it started on it, and if you finish it, turn it in, and then you don't have to worry about doing it at home. Other than that, there we go.